Hello guys, welcome back to the channel. So in today's video we are solving another LeetCode problem, that is 3133. But before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that we are given n, that is 3, x, that is 4, and we have to make a array such that, let me write that array, such that if we do the AND of all the elements present in that array, we should be getting x. But the condition is this should be in increasing order, and that's it. And as a what we need to return is this c, but there is a condition on the c is that it should be minimum. So we can't return anything, we should return something that is minimum and that satisfy this plus this. So this is our condition, that something like this should happen, and this should be equal to x, and c should be minimum. So these things need to be kept in our mind when solving, because these are the conditions that are in the problem statement. So yeah, let's take example, this example only. N is 3, x is 4, and I'm just explaining in this. We'll see how we'll make that array also. So if we have such thing such like this, and let's do the AND of 4, 5 and 6. 4 is 0 0, 5 is 0 1 0 1, and 6 is 1 1 0. And if we do the AND 0 0 1, it still gives us 4, and we can see it's in increasing order, and 6 is the minimum that we can have, which returns 4 after doing AND with all the numbers, and every number that is present inside the array is in increasing order. That we need to do, and in this case we'll just return 6. Okay, now we understood by example what basically is asked from us. Now how we'll solve this? What is our algorithm that will help us in achieving this 6? So let's see. One observation is that in this a comma b comma c, we are taking this example only. We need to see that one of this is to be 4. Why? Basic thing, that if for example take a is 4, what is required at the end, that this 4 gets propagated or it's saved, and at the final result it's still present. So if we do something like this, we get 4, and again we do this, we still get 4. So this needs to be there. So one thing is that it should be present wherever, your choice, but this should be there. So this is one thing, one observation, that 4, not 4, x will always be the part of that array or vector, whatever you want to call. Now we have to take decision about n minus 1, about the other two, and let's make the binary representation of 4. This is how 4 looks, and we are doing a AND with b. So we want to, at the end we want to preserve this. So at B, what should be there in this position in B? We can't have 0 because 1 0 and with 1 and 0 it's 0. So we can't have 1. But we can have whatever we want over here because 0 will be propagated. 0 and anything is 0. We can do whatever, but we can't do whatever because it's increasing order, but at the same time the C needs to be minimum. C needs to be minimum. This things needs to be followed increasing order, but C needs to be minimum also at the same time. So we can't have anything over here. Then that we'll decide, but that is for sure that if this bit is set, we need to get it propagated over here. If some bit is set, if some bit is set, we need to, let's scroll down a bit, we need to get it propagated gated till the end. That is for sure. That is the thing that we are doing. We need the set bits, this one, the X set bits till the end, because we need to reproduce this again after doing the AND operation with all the elements. So I hope this much is clear. Everything is clear. Now, the thing is how we will get that B and C such that it is increasing plus minimum C plus set bits propagate plus at the end the same thing, it's not plus, at the end we get the X. These three things needs to be there. Now, so this is how we can do is, our main focus is set bits should be there, should be there. So what is the minimum number we can increase? If we have 4, what is the minimum? We are talking about integer. What is the minimum integer we can add to get something in greater than 4? I would say plus 1. We did plus 1, we got 5. We got 5. Then the next thing is make sure that this next number when we do and we get 4 or X back. So what we can do, we add, or in other words we OR the set bits, not the set bits, we OR the X, because it will ensure, how it will ensure, for example, some hypothetical example, our next number looks something like this, okay, and our hypothetical X requires this at third position. So what we can do is, we can always ensure that we add this. If we add this, it automatically gets a set bit there, and when we do AND afterwards, we'll get this again, we'll get the required thing. So to get always showed that it's increasing plus minimum increase, sorry, we can say minimum increase plus a number when we do and we get x back. I think this much is pretty clear. So what we do is we do a result plus 1 and or x. So this will ensure, what it will ensure, the next number we'll get is minimum increase plus when we do and we'll get x back. So this is what we need to do, and this approach is O of n. And let me show you the code why it's O of n. So here we are returning long, so I made a long, and we just set it result first element. The basically we just set up a as 4. Okay, a as 4 over here. And now what we are doing, and as you see we are looping, and we did n minus 1 because it's basic thing. If n is 3 and we already set 1, so n is 2. Yeah, and what we are doing, as I told, we'll increase plus 1, we increase plus 1, we do OR with x to make sure we get minimum increased and a number. If we do AND with it, we'll get x back. This is what we are doing. Minimum increase plus if we do AND, we get the x back. That's the thing. And after that we'll just return that number, because we just need to return the last. Over here you can see we just need to return 6. So let's submit it for the example test cases. And yeah, it's running fine. Let's submit it. And yeah, it's getting submitted. So I hope this much is clear. This is O of n. I hope this much is clear. You can stop the video over here and like the video also, because what I'm going to discuss afterward is kind of little tricky. So yeah, it's kind of observation. I did brainstorm on it. Even I didn't come up with it. I got it from discuss, LeetCode discuss and editorial. So it's kind of observation, and I would have a comment about it when I'll get more clarification of it. But it's just an idea. I would like to share with you so that you can also research on it. So I would suggest, this is the end. You can have this approach. It's quite fine. Even if this comes in an interview, that is quite fine. Getting to this is kind of difficult on its own if you see this for first time. So this is the end. Not mandatory to move ahead or watch this video. You can just like, comment. Yeah. So let's just discuss quickly what is that thing we can do. It's kind of O of 64 basically. That's what int size in LeetCode. So let's see, it's kind of O of 1. Some places they have written O of 1. So let's see what they are doing is. So if you see that in that 4, this 4, and if we get to that 6, how that 6 looks, you see that we just did set this bit. We just did set this bit and we got that last number, which is following that increasing and minimum thing. And when we do that and with all the numbers, we'll still get the x back. So in this approach, what we are doing is we just convert this x to bits, and what we do is we look for a bit which we can set so that we get a minimum increasing number. At the same time, we get a number that when we do a AND with it, we'll get x back. We convert the bits, but how we'll know that this bit needs to be set? How we'll know this bit needs to be set? So what we do is we convert this n minus 1. So it's basically a gap between the last. If you see, what's the gap between the last is 2 places. In the final number, this 6 and 4, there is 1, so there is a gap of 2. So this 2, if we convert it to bits, so it represent like this. So this conversion of this gap, this n minus 1, if we do, we get something like this. And this tells whenever we find a unset bit in the x, if we just replace that bit, we'll get a number that is following these things. Yeah, so it's kind of observation that this n minus 1 gives us a binary representation that we can use whenever we traverse over this. When we traverse over this and whenever we find the unset bit, we'll get we can replace that bit, or we can say set that bit, and we'll get desired minimum number n minus 1, n minus 1th place number. So yeah, let's show you the code. I did submit it. Where is it? Yeah, so this is what it looks like. We are converting that x to bits in C++. That's how you can do it. I don't know about the other, but you can, there would be a similar thing in other also. So this is what we do for n minus 1 to get that thing which bit can be set. Yeah, or we can say which bit can be replaced. So we are looping over 64 because that's the size of int in LeetCode. And what we do whenever we find this bit unset in x, we are setting it with the bits n. N means this one, and we have another pointer over it, this position of n. This is another pointer, and we increase it, and afterwards we are converting back to that number because we can't represent that bit. We'll just get this number back. Okay, that's what we are doing. If that bit is set, we'll just increase that power, basic conversion, bits to a number, and after that we are just returning it. Let's run this thing also. It's kind of observation based that how we got this thing n minus 1. In future, if I'll find something, I'll add it in the comment section, but this is what I say. You see, it's quite fast. This approach is quite fast. I hope you got a new idea that you can work upon it. You can also try, have a look how this observation went to getting applied over here. Uh, how we get this idea of that if we do n minus 1, this is what, if we get the binary representation, we'll get which bits need to be set so that it's increasing minimum, and when we do a AND. So yeah, This is what I understood. So yeah, I hope you also do some research on your end. And yeah, I hope you like this video, because it takes a lot of effort to make such videos, because I make in one shot, no edit and all such that. So yeah, so consider subscribing to the channel, liking this video, commenting whatever you feel. It's even it's bad or good, I'll try to have a look at it. So yeah, you guys are awesome. You have to do what you have to do, so keep grinding. You guys are awesome. See you in the next one. Bye bye.